Hello, Subhash Gubba here, and
Sid here.
Sid here from the team for CompArch, the 8-bit Minecraft CPU. We're going to talk and give a brief tour of our CPU and how we build it. So yeah, let's begin.
So
Cool.
this is our artificial clock right now. So basically every 2 seconds it will make one cycle,
Yep.
and the clock will pulse every 2 seconds.
Yeah.
And so the first thing we're gonna explore is the program counter.
Right. Okay. So, basically we have the clock hooked up to a transmitter, and we have a receiver right here on the frequency 5000. So this is how we're primarily going to be hooking up many of the higher level modules, essentially wirelessly. And so yeah, we can talk briefly about the program counter. So as you can see here, it has multiple states. This is represented in binary. Yeah.
Yeah, and
So
you can see every time that the clock closes, the program counter will increase by one.
right.
And basically the program counter will be fed directly into the transmitters that you see right next to the lights. And those transmitters will send a signal to the instruction memory, which we will visit now.
Yep. Okay. So this massive structure right here is the instruction memory. And so first we start off by building one layer, as you can see here. It goes off for a very long time, and then we stack them using mcedit 7 more times to give us a total of 8 readings that we could have, 8 different instructions. So you want to talk a little bit about? Sorry, 8 different bits. Yeah.
Yeah, so basically we have our selector pins going into here. This is where the program counter is entering in data. And the program counter will select which byte it wants from the instruction memory, and the output of the instruction memory will be here. So right now, bits 2 and 4, the second most significant bit and the fourth, okay, now it's the first and third most significant bits are lit up because that's the instruction memory at that point in time.
Yep.
And this instruction will go into the instruction decoder.
Yep. So the instruction coder is essentially looking at the bits that were, so in the back we had a bunch of toggleable switches, and these switches were basically in binary giving the name of the instruction. And here we have the equivalent of a massive lookup table in which it actually checks what from the instruction memory. It takes those bits in and it's able to decode the instruction. And so essentially these control flags right here, our opcodes, are lit up according to what is on per instruction. So right now we have the read write. Is this the register write enable or the read write enable? Register. Okay, so we have the register write enable, and oh, just changed again. So now it's the immediate 4-0 bit, and as you can see,
Glitching. That's
yeah,
because the Red Power mod pack in Minecraft has very serious propagation delay. So it will
right,
take some signals a while to reach places that are far away, and because of this, some glitching may occur.
right,
This is something we plan to address in a future iteration of the CPU.
right. So yeah, now we're going to we'll talk a little bit about what's here right now. So we have some multiplexers, and yeah, so this is essentially, I believe this is the 2 to 8. No, okay, I can cut it out of the video. It's fine. Okay, now we'll move on to the ALU. Alright, so here we have the ALU. I believe it only has the function of adding.
Yes,
Um,
that is correct.
because our program that we run only really needs that. So yeah.
It also has the ability to tell you if 2 bytes are the same value.
Right, right,
We need that for jumping instructions.
right. Yep.
Now we're gonna walk over to our register file.
Yep. Okay, let's go.
It's a long distance away.
Yeah. I can get there faster by. We should have set up portals.
No, yeah.
Would have been a lot faster.
We're gonna visit this hotel. It's called the register.
Yep.
So basically, the register file holds our register file holds a total of 8 different registers,
Mhm.
each a byte long. And we
Uh,
four specific registers. We have four general registers. These four are the four general registers. And the next four registers are specific. They're registers that are specific to our computer architecture, and
right.
many of the instructions and modules will read directly off of these registers.
Mm-hmm. And as you can see, these are also wirelessly transmitting these to the next module. And yeah, that's the register file. This is the multiplexer that it utilizes. Beautiful. Okay.
So
Should we move to the instruction memory next?
the data memory.
Or sorry, that's what I meant. The data memory.
So we're gonna move to the data memory next, and in the data memory, what happens is that we have a register specifically for the data memory pointer, and whatever value the data memory pointer is set at is the value. That's location in the data memory which we fetch values from.
Right. So as you can see, many of the chunks are loading right now, and if you look in the upper right corner in the minimap, we have essentially 8 of these deciding hot dogs, as we call them. This is how, so essentially the value from the instruction, or from the data memory is transmitted to these, and then it's able to decide what exactly it's reading. So we'll go over to this giant area. That's
This
a lot.
is the pancake section
Yep.
of our data memory, and what this does is it's pretty much a series of multiplexers, and from this the values, the data memory pointer will go into these,
Right.
and these will help select out the location of the value of what we want, which byte we want for the data memory.
Right. Essentially, we have these little data transmitters right here. The decimal number on here corresponds to the number in binary that we're actually looking for on here using these wires. So, for example, this would be 111001, and that would correspond to that number in decimal. So yeah, this is essentially repeated many, many times. I believe around 1,000. So we had to manually go in and change each of these values, which was loads of fun.
Yeah.
So yeah, MCEdit did help a lot in the sense that we could stack many of these repetitive architectures. However, we still had to manually change the actual bits that were, or the actual numbers that were being used for frequencies for transmission of data.
It took us a while.
Yeah, quite a bit of time. So now we're going to head back over, and here we're happening upon the instruction memory again. I can briefly show you. We had to go through and manually toggle per instruction each of these bits here using these levers, and that's essentially what decided which instruction we were dealing with.
In a future iteration, we're hoping to find a mod which will input a CSV and hopefully automate this process, but
Yeah.
that's not looking very hopeful.
Right. Alright, cool.
And yeah, this is basically our entire CPU.
Mm-hmm.
We had a lot of fun building this. Fun fact, our entire team spent 22 hours in one sitting.
And built this.
Yeah.
Yeah, it was basically a hackathon.
We did spend some time here and there before that.
Yeah.
Obviously.
A lot of planning beforehand, and most of the execution happened.
Yeah, and
Yeah.
painting the architecture also.
Right. Alright, cool. If you have any questions, you can contact us, and we'll be sure to try to answer them for you.
Preferably, you can just Google the information so we don't have to.
Yeah, that works too. Alright, cool. Thank you for watching. See you later.